There have been various experiments depicting the radiation shielding properties which were performed on the planet Earth. These experiments, however, have been performed in artificial lunar atmosphere using synthetic or similar materials due to scarcely available actual lunar soil brought back from various moon expeditions. Our experiment, the Canopy of Life, aims at testing the radiation shielding properties of lunar regolith on the surface of Moon itself in its natural environment. The experiment aims at establishing the relation between the thickness of lunar soil layer and the radiation dose reduction due to this layer. It will help us in determining an optimal cover thickness for the regolith. This will in turn provide relevant data which will be beneficial for setting up future lunar colonies.
Our experimental setup consists of two non-concentric cylindrical walls which would enclose lunar regolith between them. It also consists of two radiation sensors which can rotate 360 degrees along the periphery of inner and outer cylindrical walls. Once the setup is initiated, the soil transport mechanism consisting of a drill and a vertical screw conveyor will drill the lunar surface and transport regolith to the chamber enclosed between the two cylindrical walls. A sensor placed inside the sensing and control unit will stop the mechanism once the required amount of soil has been transported. The two radiation sensors will then begin the task of data collection. These two sensors have a certain lag which would ensure that the outer sensor does not block any radiation incident on the inner sensor. As the two sensors rotate along the periphery, they will measure radiation dose reduction with respect to the changing thickness of lunar soil cover. Also, as we wish to measure radiation in one particular direction at a time, the rest of the inner cylinder will be insulated. The sensors will collect the data for a predefined set of time, and this will constitute the first set of readings.
In this experiment, there is a provision for rotation of the entire setup around the axis. After calculating the first set of readings, the body will be rotated by a few degrees to obtain a new orientation. At this orientation, again the radiation sensors will undergo a full 360-degree rotation and the readings will be collected. This process of rotation and collection of data at various orientations will go on until the entire setup has finished a full circle. The rotation of the main body is carried out so that the effect of thickness of soil layer can be seen on radiation coming from all the sides of the setup. After finishing the collection of readings, which will be stored in a local memory storage, the data will be sent to HHK1 at a convenient time. This data can be sent back to the planet Earth for further analysis. Radiation may pose the biggest threat to human settlers on Moon. Therefore, a proper protection system needs to be put in place with minimal dependence on the resources from the Earth. Hence, using in situ resources will be an effective and sustainable solution to this problem.
Our experiment, the Canopy of Life, will provide the necessary scientific data to the mission designers and planners to design suitable habitats for future lunar residents. It will therefore be a first step towards expanding our reach beyond a planet we have called home for 1 million years.